Welcome back, Wolfpack. Today's lesson is 4.2, Triangle Inequalities. The essential question continues to be, how do triangle properties assist in solving real-world problems? So you might have thought before that you could just take any 3 pieces of paper, 3 straws, or 3 sticks, and make a triangle out of them. But in fact, that is not true. There has to be a relationship between the 3 sides of the triangle in order for them to actually make a triangle and close all the way. The triangle inequality theorem states that the sum of any 2 side lengths of a triangle is greater than the 3rd side or the remaining side. So if I add up 2 of the sides, it has to be bigger than the 3rd side. Not equal to, not less, but larger than. So let's see this in action. We're going to use the triangle inequality theorem to tell whether a triangle can have sides with a given lengths. And then we have to explain. So I'm going to add up 4 plus 8. And see if it's greater than 10. 4 plus 8 is 12. 12 is greater than 10. Yes, it works. So the first 2 sides are greater than the 3rd. So now I'm going to check 8 plus 10. Is 8 plus 10 greater than 4? 8 plus 10 is 18. Is that greater than 4? Yes, it is. So that works. And so now I have to check 4 plus 10. 4 plus 10 is greater than 8. 4 plus 10 is 14. 14 is greater than 8. Yes, it works. So when I add any of the 2 sides, it is greater than the 3rd side. But we really don't have to check all of the sides, okay? So let's go ahead and answer this question first, and then I'll say why. So you would say yes, because the sum of any 2 sides, I'm going to move this down, of any 2 sides is greater than the 3rd side. Now, one thing I want us to think about, let's use some logic. Really, the only 2 numbers I needed to check were the 2 smallest numbers, 4 and 8, and add 4 plus 8 together. Because I know that if I use the number 10, 10 is bigger than 4. And so if I add 4 to 10, of course it's bigger than 8. Or if I add 8 to 10, of course it's bigger than 4. So really, all I have to do is check the 2 smallest sides. And if the 2 smallest sides are greater than the 3rd side, then they're all greater than the 3rd side. Okay, so really this right here, which I'm going to erase, we do not even need to do. Okay, so let's check the next 2. So my 2 small numbers are 7 and 9. So I need to see if 7 plus 9 is greater than 18. 7 plus 9 is 16. Is that greater than 18? No, it's not greater than 18. So you could not have a triangle with the sides of 7 inches, 9 inches, and 18 inches because 7 plus 9 is not greater than 18. So you need to say no because 7 plus 9 equals 16, which is not greater than 18. If you want to abbreviate a couple of things or use some symbols, you are more than welcome to. So again, using some logic, we did not have to check 9 and 18 because obviously 9 and 18 are both bigger than 7. So if I add them together, of course the answer is bigger than 7. I also didn't need to check 18 and 7 because 18 by itself is already bigger than 9. So of course, if I add something else to 18, it's still going to be bigger than 9. So you really only have to check the smallest 2 numbers. Let's look at example 2. We have to find AD. The answer must be an integer. Okay, meaning it has to be a number. It's not going to be a whole number. It's not going to be a fraction or a decimal. So we need to find AD. So I'm going to look first at triangle ABD. So if I have 2 sides, I can find what the third side might be, the range of sides. So what you need to do is you take the two sides and you add them together. 4 plus 8 is 12. And you take the two sides and you subtract them. 8 minus 4 is 4. That means that our side has to be greater than 4, but it has to be less than 12. So it can be any number bigger than 4, so 4.1, less than 12, so 11.9. But if I compare it to the other triangle that it's connected to, it has to be 5 plus 15 is 20, and 15 minus 5 is 10. So this time it has to be greater than 10, but less than 20. So I need a number that's bigger than 10. So obviously if it's a greater than 4, but it also has to be greater than 10. So it's going to be greater than 10. It has to be less than 12 and also less than 20. So obviously less than 20 is out of the picture because it has to be less than 12. So what's a number that is bigger than 10 but less than 12? Remember, it has to be a whole number. The answer is 11. AD has to be 11 because we had two sets of circumstances that it had to fit. So not only greater than 4 but less than 12 also had to be greater than 10 but less than 20. And 11 is the only number that was bigger than 10 and less than 12. We will do example 3 in class. It's the same exact thing. You're going to add the two numbers together, subtract the two numbers, and that's going to give you the range that it could be. So your answer is going to look like something more along the lines of this that we had originally, that we were able to narrow down the exact answer. So example 3 is finding a range of values. What could the answer be? Okay, so we'll do that in class. Okay, backside, relationships of sides and angles in triangles. The larger angle is opposite the longer side, and the longer side is opposite the larger angle. There are exceptions, isosceles and equilateral triangles, which we'll talk about a little bit. But it kind of makes sense. The bigger the angle, the bigger the side is across from it. If you look at the example A, angle A is a big blue partial circle, and side A is across from it, and it's the biggest side. Okay? Angle C is opposite side C, and angle B is opposite side B. So, example 4 says, for each triangle, order its angle measures from least to greatest. Least to greatest. So, I don't know anything about its angles. It didn't mark any angles for us, but it did mark the sides for us. So, if we want the angles least to greatest, the sides opposite it would be where we would start. So, I'm going to look at the sides, and the smallest side is side 15. So I'm going to mark that as number 1. BC is the smallest side. AC is the second smallest side. So that's going to be side number 2. And AB is my largest side. Excuse me. Sorry about that. Side 3. Okay? So my smallest side is BC. Well, the angle opposite BC will be my smallest angle, which is angle A. My second smallest side is side AC. The angle opposite AC is angle B. That's my second smallest angle. And then my largest side is 40 degrees, AB. Well, the side opposite 40 degrees is angle C. So that's the angles marked from smallest angle to largest angle. Again, we don't know the values of those angles, but we know the ranking of them from smallest to largest or least to greatest because of the sides opposite them. Now, letter B is a little bit harder because they didn't give us a triangle, but all you have to do is draw it. So you're going to just draw any random triangle, label the points, J, K, L, and then label the sides they give you. They said that JK was 10, KL is 12, and LJ is 15. So doing the same thing again, from least to greatest. Well, I don't know the angle values, but I do know the sides. So I'm going to mark the sides from smallest, which is least, to greatest. JK is the smallest side. KL is the second smallest side. And JL is the third smallest side. So the side JK is opposite angle L. The side KL, okay, sorry about that, guys. So again, the smallest side was JK, which means the angle across from it is the smallest angle. My second smallest side is KL, and so the angle across from it is angle J. And then my third largest side, or my third smallest side, my third smallest, my largest side, is angle JL, is side JL, and so the angle across from that is angle K. Right? Also, you could have looked at the problem and seen that if you look at the relationship JK, side JK includes vertices J and K. So the angle opposite it is the one letter that's not a part of it, which is angle L. Okay? Side KL, the angle opposite of that is the vertex that's not included, angle J. Okay, so that's just a little hint if you don't want to draw a shape, but it's always a good idea to draw the shape and make sure you're doing it correctly. Okay, so that is example 4A and example 4B. Okay, we're going to do examples 5A and 5B as well as example 6 in class. But if you have any questions, please make sure that you are writing them down in the margins. This is not a hard lesson at all. It's very easy, self-explanatory, makes a lot of sense. Really just a lot of adding and subtracting, ordering numbers from smallest to largest. So you're capable of doing this if you put your mind to it. Hope you have a great day, Wolfpack. See you next class.